on. Okay, so I'm going to talk about the simulation hypothesis. This is the agenda. What is it? Is it a new idea? Actually, it's a very old idea, but I'm going to address it mainly in modern terms. There are arguments both for and against, and I'm going to present both of those. And then, of course, if it's a real thing, there should be evidence for it, and it can be proven. So there have been attempts to find evidence for simulation and prove that it's actually a thing. And then I'm going to talk about how our modern technology interfaces with this whole concept. And then I'm going to present some people who actually believe that we live in a simulation. And then I'll talk a little bit about the implications and some of the questions that we should be asking in relation to this. In modern times, it was first proposed by Nick Bostrom back in 2003. Now, Nick Bostrom is a philosopher who's written several books. He wrote one about artificial superintelligence and what a threat it is to humanity. He wrote about the fragile state of our world, where we pull ideas out of a box and eventually we're going to pull an idea out of the box that's going to destroy us. He's a very pessimistic sort of guy. And of course, when he came up with the simulation hypothesis, it was kind of a pessimistic idea from him as well. But basically, it's this. There are enormous amounts of computing power today, and it's only going to grow, and there will be even bigger amounts of computing power available to us in the future. And this is proven by the fact that if you look at the cost of storing data, back in 2000, it was about $12.50 a gigabyte, and now it's down to less than a half a cent a gigabyte, and this curve continues down. It'll start to flatten out just because of the limitations of physics. Computing power does not seem to be slowing down at all. It's gone up 10,000 times since 2000 to 2017. Huge growth. And if you know anything about how artificial intelligence and large language models and self-driving automobiles work, they all work on just massive amounts of data. And if you look at how much data we had back in 2000 as compared to how much data we have now, and it's being collected in huge amounts every day, this data growth is going vertical just about. All of that adds up to the fact that we might be able to have enough computing power at some time to simulate consciousness. So how much computing power does that take? Well, for a human, we do 10 to the 17th calculations per second. So if you want to simulate a human being's consciousness, you need computing power that will do 10 to the 17th calculations per second. And if you want to simulate all of the humans on Earth, and say there are 10 billion, there aren't, but say there were 10 billion, when we get to the point where we can do it, 10 billion humans would mean you need 10 to the 17th times 10 billion, and you get 10 to the 26th power calculations per second. That's a lot of calculations. Well, how far away are we from that? Mm-hmm. Well, as of 2022, we have a system at Oak Ridge Laboratories that does 1.1 exaflops. That's 10 to the 15th calculations a second. Not enough to simulate consciousness, but pretty darn powerful. But again, you'd have to multiply that by 100 before you get to the point of simulating a single conscious human being. Now, large language models simulate intelligence, but it's only a simulation of intelligence behavior. It's not a simulation of consciousness at all. It's basically an illusion. Eric Dreckler, who was a PhD at MIT, outlined a system the size of a sugar cube that would do 10 to the 21. So imagine that. There's a computer he has effectively designed the size of a sugar cube that could simulate the intelligence of a human being, but not enough to simulate the world. Robert Bradbury, who has passed away, has conceptualized a planet-sized brain capable of doing 10 to the 42. So at least theoretically, we've got computers that could simulate all of the people on the planet. Now, a technological society could eventually achieve the capability of creating a computer simulation that is indistinguishable from reality to the inhabitants of the simulation. So if you were a simulated human on a simulated world, would you even know that you were a simulation and not the real thing? And that raises some philosophical questions, which we will get to. A third thing to think about is, why would you do simulations? Well, it turns out there is a huge amount of value in simulations. Why would technological societies do simulations? They fall for entertainment. That tends to be where things start out. That's where the money is. This is a screenshot from a simulated world called World of Warcraft. I used to work for a company, AT&T, that hosted World of Warcraft. And we would have, in real time, 3 million people playing this game simultaneously. And in this simulated world, we could talk to each other, we could go on adventures together, and it was very absorbing. We would also use simulations to things like education. And it turns out that large language models simulating actual people who have huge amounts of knowledge are being turned towards education. So eventually, and not in the very distant future, you will be able to talk to a simulated Einstein, for example, and have him explain to you the theory of general relativity and answer questions for you and so on. And if you wanted to learn about biology, you could go talk to Robert Sapolsky, or you could have Robert Sapolsky and Einstein in a room together and ask them to talk to each other about the meaning of their research. And you would learn a tremendous amount from doing this. Another thing you could do is tourism, and not just visiting real worlds, but you could visit places like Alice's Wonderland, and go talk to the rabbit and talk to the caterpillar and talk to the knight. You could also do simulated time travel. You could go visit the 1893 World's Fair and see what was going on there. You could see what life was like. When we see a portrayal on television of people living in a world where men are incredibly misogynistic, modern people look at that and shake their heads and say, oh, it couldn't have been that bad. Well, if you could simulate going back to the 1950s, the 1940s, and go into a boardroom and see how people talk and how they treat their secretaries, who are all women and only women, this might give you a very realistic point of view. You could also be given a very unrealistic point of view depending on who created that simulation. Mm-hmm. You could do studies in economics, right? What if we create a world where we don't have to resort to fossil fuels? What would be the effect of that? What would be the effect on the environment? What would be the effect on economics? What is the effect of advanced artificial intelligence going to be on who loses jobs and who doesn't? And interestingly, before large language models, our view of who was going to lose jobs was truck drivers. But now it looks like a lot of middle-class people, middle managers, are going to lose their jobs because large language models do middle management kinds of functions very well.
Designers
you can do
artists.
market. Alice, did you say something?
Yeah, designers and artists also are in danger, surprisingly. Mm-hmm.
Yeah, and that was kind of a shock. Market research, what will you pay for a product? So all we have to do is simulate a demographic, simulate the product, and then present it and put prices on it and see what the uptake is and so on. Just use a very complex model. That's a simulation of people in a buying demographic. You could simulate things like engineering. How powerful can I make a computer? Well, I don't have to actually build it. Now, I used to be in the computer business in its early days, and we actually simulated our next computer model on the current computer model to see if it would run, how fast would it run, how many calculations could it do, how much memory did it need. And we did all that without building the computer, so that when we did build the computer, we knew it would work. And the more complex simulations get, the better they're going to be at it. And we also know now that we could simulate or we could build a computer that can simulate the next generation of computer, and the current computer can be as smart almost as a human engineer, which means at some point the computer building the next computer is going to be more advanced than anything a human could do. And we also go into what's the effect on art of being able to do simulations, the environment, the evolution of species, star systems and galaxies, the behavior of animals and humans in society, and war games and things like that. So simulations have value. This is an actual simulation of the birth of the universe that was done on a computer. There is a value of simulations. It's undeniable. So our descendants are probably going to run simulations. And one kind of simulation would be ancestor simulations, where they simulate how the world of humans has evolved over time, how civilizations have evolved, how human interactions have evolved, and then project that into the future. And that has tremendous value, because now you can do things like are being portrayed in the Foundation series, Isaac Asimov.
Oh yeah, I enjoyed it, but I think I should read the book right now. I think it has more details that contradict the screen version.
Yeah, well, that was written a long time ago too. So, that's just going to eventually get to the point where maybe it will work. And such a society that could do simulations of this depth wouldn't do it just once or twice. They'd have many simulations, right, for different purposes and different goals and so on. And left to run long enough, the societies within the simulations who don't know they're simulated would be able to create their own simulations. They would invent their own technologies. They would build their own computers in these simulations. And these would also be indistinguishable from reality to the sub-simulation inhabitants. So you'd have layers. Now there would be some base reality. There would be the first people to do this, who would create another layer of simulated people, who could then create a third layer above them of simulated people. So there are 5 assumptions here that we can address. The first is, it is or will be possible to simulate consciousness. That's going to happen. We know how many calculations a second it takes, and we know how many calculations a second it would take to simulate the entire population of the planet. Technology is going to progress. It's not going to stop unless civilization stops or civilization gets destroyed. Now, one of the assumptions then moving forward is that advanced civilizations don't destroy themselves, but we have no evidence of that, because if you look at the Drake equation and the Fermi paradox, we haven't met any advanced civilizations. Now, we don't know if they exist, but they apparently do not. And if they don't, maybe there's something that wipes out every civilization when they get to a certain point. Mm-hmm. And Nick Bostrom will give you several examples of what those great filters could be. The fourth assumption is that if you have advanced civilizations with this technology, they will want to run simulations. And finally, if there are a lot of simulations, you are probably in one. You are probably simulated, and I'll show you how that works too. So this became a really popular idea when The Matrix came out, because that was a world of simulated people being simulated in a computer system. Now, there are 3 unlikely seeming propositions, but one of them is probably true. The first is that the fraction of human-level civilizations that reach a post-human stage, capable of running high-fidelity ancestor simulations, is close to 0. All right, and that's highly improbable, because unless something prevents it technologically, we're getting very close to being able to do this. And if we're getting close to doing it, a civilization that's existed for, say, 100,000 years longer than we have should be able to get to that point. So why would it be close to 0? Probably not. If it's true, though, then we will almost certainly go extinct before reaching post-humanity. Now, there's a fellow, Sir Martin Rees. He's the co-founder of the Center for the Study of Existential Risk at Cambridge University. He says that civilization has about a 50-50 chance of making it through the 21st century. And this is based on very detailed and very intensive research on the part of his community. And this means that the average American is almost 50 times more likely to witness the collapse of civilization than to die in a motor vehicle accident. And that's a scary thought, especially if you've been on the turnpike in New Jersey. The second proposition is that the fraction of post-human civilizations that are interested in running simulations of their evolutionary history or variations thereof is very close to zero. And that's highly unlikely. I mean, if I could run simulations, I would certainly do it. I'd love to talk to Einstein. I'd love to talk to Darwin. And having access to a good simulation of somebody of that caliber would be very interesting to me. And there are other people who might want to talk to Yogi Berra. Fine, simulate Yogi Berra. If this is true, then there must be a strong convergence among the courses of advanced civilizations so that nobody cares to do it. Also, highly unlikely. Anybody with an intellect and the capability to do this, in my estimation, would want to do it. And the third possibility is that the fraction of all people with our kind of experiences that are living in a simulation is highly, highly likely. And if that's true, we are almost certainly living in a simulation. And Nick Bostrom rates the probability at about 20%. There's a 20% probability, according to him, that you are a simulated person living in a simulated world. Now, this three proposition trilemma points out that a technologically mature post-human civilization would have enormous computing power, and if even a tiny percentage of them were to run ancestor simulations, the total number of simulated ancestors in the universe would greatly exceed the total number of actual ancestors. So we can do some math. The probability that we are simulants equals the number of simulated minds divided by the sum of simulated minds and real minds. So if the number of real minds is about 10 billion, and they're running 1,000 simulations in that 10 billion, then the number of simulated minds would be 1,000 times 10 billion. That would be 10 trillion. So the probability calculates out to 0.999%. So the probability then that you're living in a simulation is really close to 1. It's really close to definitely. Now, going way back, this is not a new idea. There was a Chinese philosopher, Zhuangzi, who noticed sometime around 300 BCE that his dreams of being something other than human were indistinguishable from his experience of being himself. He could not say with certainty that when he was dreaming of being a butterfly, that it wasn't him being a dream of a butterfly being a human. Now, if we look at this from modern scientific point of view, the number of neurons in a butterfly would not be adequate to simulate a human. But the idea is there. I've been in dreams where the reality of my dreams certainly fooled me into thinking it was a reality, and I've woken up frightened or dreamed I was falling through space, and it was indistinguishable from reality. So Zhuangzi said, if that's a possibility, then maybe this is not the real deal. Descartes posed the question that, maybe we were just being manipulated by evil demons, making us think things that weren't true and see things that weren't true and believe things that weren't true. George Berkeley, an 18th century philosopher, said that appearance is reality. He says, if you see something and your mind perceives it as real, it's as real as it has to be. And if you don't see something, like the state of Florida, for all you know, it doesn't exist. It may not be real at all because you can't see it, you can't sense it with any of your senses. Then, as far as your brain is concerned, it doesn't exist. And the fact is, until I started talking about Florida, You weren't thinking about it. It didn't exist for you. And then there's religions, which I'll talk about in a minute. In more recent years, one is now asked to imagine a mad scientist who has extracted one's brain and keeps it in a vat and is stimulating it with electrical signals, replicating the sensory input that the brain would have had if it was interacting with the real world. And here's a comic that illustrates the idea. Hey, what if we're all just brains in a vat, sitting in a lab somewhere, hooked up to wires and electrodes and shit, our entire lives just a hallucination of electrical pulses? Gosh, I hope not. Yeah, freaky. Several models exist of this. Here's one by Edward Friedkin. He postulated that the universe is at bottom some sort of computer. Okay, now the universe is subject to physical laws, and the physical laws are obeyed by reality, and they kind of roll out without any thought. They just calculate what the next instant of time is going to look like. Stephen Wolfram has taken up that idea in a book he wrote called A New Kind of Science. He says that at the fundamental level, which is the very smallest cellular reality down at the Planck level, physical reality might just be some sort of automata. At that size, at that small amount of reality, the bits interact with each other and they're governed by simple rules. And those rules form all of the basic matter that exists in the world. And then they follow all of the rules at each level up. And if you remember my talk on emergent theory, this plays into that. Another hypothesis, and this is where we get into religion, and this was very common up until, well, it's been common for most of history, and this is the creation hypothesis. There's a God somewhere, and God is outside of physical space-time. That means he's not part of our reality. And in fact, in modern thinking, God doesn't even have to be supernatural. He just might be in the next universe up or down, depending on how you look at it, creating a simulation using the latest technology. Another theory that was prevalent for a long time is this dichotomy theory that says that we have minds that are non-physical, that exist independent of our physical bodies. And if that's true, then of course, when you die, you can go to heaven. Your mind, your spirit, your soul, whatever, could go to heaven. Or you could be possessed by a demon, where your physical body is possessed by a different mind, and so on. These are all simulations of a sort. And then there's the current one, where the computational processes underlying physical space-time were designed by somebody else as a computer simulation of a world. And this is the current thinking and simulation hypothesis. So can you argue against these things? Because the evidence, from a philosophical standpoint is pretty strong. So researchers at the University of Oxford have calculated that even just to store the information about a few hundred electrons on a computer would require a memory system that is built of more atoms than there are in the whole universe. So they're saying, no, not possible. You can't have a computer big enough to simulate all of the electrons in the universe and all of the neutrons and all of the atoms and all of the molecules, never mind all the people and their thoughts. Another bit of research suggests that it's impossible because there's something called the quantum Hall effect. If you have to have a computer to simulate a subatomic particle, then if you want to simulate another subatomic particle, well, you got to have another computer. And it's made of subatomic particles, right? And if you want to have another subatomic particle, you have a third computer and so on. And pretty quickly, you run out of the ability to build all of these computers. But then there's the Fermi paradox. There's no evidence that we are not the one and only inhabitants of the base reality in which we live. As far as we know, we're it. So if we're the only reality in the universe of thinking peoples, then, we're not doing it, so nobody's doing it. We have no evidence at all that there are other civilizations in the galaxy, although lately, people are seeing a lot of UFOs and taking pictures and things that we can't explain. Still doesn't imply other civilizations. So we are the only living present there is. There is no general artificial intelligence yet. Right now it's predicted to come before the year 2030, so it's imminent. But at that time, we're going to be the ones running the simulations, all right? So it hasn't started yet, and when it does, it's going to be us doing it. So is there any actual evidence for it? And this is something everybody's looked for. Now, one of the early examples of evidence for simulation is solar eclipses. And the premise is this. The moon is just the right size and just the right distance from the Earth so that every so often it passes between the Earth and the sun and blocks out the entire sun other than the corona. So clearly, this is designed. Pretty weak argument. Then there are people that say, well, I had a premonition, I was going to get on the plane, but then I decided not to get on the plane at the last minute, and the plane fell out of the sky, and if it wasn't for that premonition, I'd be dead, right? So where do premonitions come from? How did this simulated person get a glimpse of the future of the simulation? Then there's deja vu. Now there is, that's a common thing that psychologists explain just by the way the brain works, so that's not a very strong argument for a simulated universe. And then there's past lives, and there is one example I found. I did a lot of looking, and I did find one that's pretty convincing. This is from 1930. There was a 4-year-old girl named Shanti Devi in New Delhi in India, and she told her parents that she had once lived in a place called Mathura. She was the mother of 3 children, and she died in childbirth. And her previous name was Ludgi. Because the girl continually related the story, her parents investigated, and they found the village of Mathura, and they took her there and found out that there was a woman named Ludgi who had recently died within the past 5 years or so. And they took her to the village, and she started talking the local dialect, recognized her previous husband, recognized her children, and gave 24 accurate statements matching confirmed facts about Ludgi's life. Now, that was in 1930. I don't know how convinced I would be by this evidence, and this is the only thing I found that was even moderately strong. The Fermi paradox I've already talked about. And then there's the whole concept of, the universe is so carefully designed that it must be designed. It couldn't have happened by accident. And the evidence for this is things like, if gravity was just a little bit stronger, stars would burn out too fast and the universe would contract. If gravity was a little bit weaker, stars wouldn't form at all. If the cosmological constant was a little stronger or a little weaker, the universe couldn't exist. If the strong nuclear force was a little bit stronger or a little bit weaker, atoms couldn't form. Or couldn't stay formed, or would collapse upon themselves. If the weak nuclear force was a little bit off, then atoms couldn't stay together. And then there's a bunch of other things. There's the electron charge, there's particle mass, and about 24 other things that all have to be exactly what they are, or the universe couldn't exist. Therefore, it must have been designed. But then there's the anthropic principles that are used to explain this. The weak anthropic principle is the reason the universe looks like it was so carefully designed is if it didn't exist, we wouldn't be here to look at it. So the fact that we're here to see it means we were lucky enough to come into existence in the one universe that happened to be, just by happenstance, perfectly designed or perfectly balanced. But it's just one of many possible universes, and we're just lucky enough to be here. The strong anthropic principle is that the universe was designed so that we could be here to observe it. And this is where you get into things like religion and simulation theory. And the third is the participatory anthropic principle. And we're going to get into this a little deeper as we go forward. But this one says the universe at the level of quantum theory doesn't exist unless it's observable. Therefore, the universe wouldn't exist unless there was somebody to observe it in the first place. So we have to be here with our consciousness, otherwise the universe wouldn't exist. But I think there's a horse and cart theory problem with this. And then you get into things like what's going on in the world. And I bring up Donald Trump and Shakespeare as examples of this. How can a person like Donald Trump and a person like Shakespeare, who could write so beautifully and talk about how humans were like gods, how could we all exist at the same time in the same place, relatively speaking, and all be humans? And then there's the whole business of quantum uncertainty. I'll talk about that in a bit. In 2017, a paper was written on testing simulation theory. They did a Kickstarter campaign, they raised a bunch of money, and they did their experiments. The people that did it were highly qualified people from the California Institute of Technology, JPL in California, Main Street Multimedia. They wrote a detailed paper about what they were going to do, and basically what it says is, if we are in a simulation and we're being simulated on a computer, that computer has finite resources that have to be conserved. So how do you simulate a reality as complex as the one we live in a computer that has finite resources? Well, basically what you do is what they do in computer simulations in video games. You only render in the game what the player has to be able to see. So when you're in a room, the room is being rendered. The table in front of you is being rendered. The computer sitting on the table is being rendered. But upstairs, the bathroom is not. Right now, the bathroom doesn't exist upstairs because you're not looking at it. Now, how could you prove this? Well, you do something called a wave-particle duality experiment to expose this. This is what they proposed in their paper. Although from a broader perspective, the issue being addressed is the nature of reality, they say they're going to avoid philosophy, and they're just going to ask one question: what causes and determines the collapse of the wave function? So what is that all about? Well, it's the two-slit experiment. You send any kind of subatomic particle, or not even subatomic, atomic level particles, at some kind of barrier, a screen that has two slits in it, and the result that you get is a wave interference pattern that you would get as if you threw two stones into a pond. The two waves coming from where the stones landed would interfere with each other and make this interference pattern. But when you observe the particles going into the two slits before they go in, and the sensors can tell you which slit the particle went through, you no longer get the interference pattern. You get a pattern that says, well, if the particle goes through the slit on the left, it lands on the left of the screen. And if it goes through the slit on the right, it lands on the right of the screen. And you get particles. Now, you didn't change anything in terms of what you sent through the slits. You only changed the fact that you were observing the particles going into the slits in the first place. So here's a schematic of that. And it says, if you generate the particles and you put a detector in front of the two slits, you get a particle pattern. But if you don't put the detector in there, or you don't turn it on, or you don't record it, you get a wave pattern. So the first thoughts when scientists saw this is they said, well, maybe the detector is getting in the way, and maybe the detector is causing this wave function collapse that's apparently happening. So then they said, well, let's put the detector on the other side of the slit so we can see after it passes through the slit which way it went. And it turns out that when you do that, you get the same effect. If you record in any way the particles after they came through the slit, you get the particle pattern. But if you turn it off, you get the wave pattern. So if you observe it in front of the slit or behind the slit, same effect. So then somebody came up with this idea. What if we entangle two pairs of these particles and we put the recorder either in front of the slits or after the slits, doesn't matter, and we take one of the entangled pair and we look at it. If we record it and if we record it after it's come through the slits, we still get the particle pattern. And if we record it, or we turn off the recorder, we get the wave pattern. It still happens, of course, that's what you would expect. But then they also say, what if we do this? What if we take one of the entangled pair, we send it to a memory, and it's in the memory. If we leave it in the memory, we get the particle pattern. But if we erase it before the particle hits the screen, we get the wave pattern. So now there's a time element involved. If you have in memory the fact that the particle came through a slit, it looks like a particle. But if you erase the memory before the particle would have hit the screen, you get the wave effect. So again, observation is everything. And it's affected by whether you record it or erase the recording. And then there are a bunch of examples of different ways of testing whether the observation has an effect or not. And the answer is, if there's an observer, you always get the particle function. If there's no observer, you always get the wave function. So the observer has to be there, and the observer always has the same effect. John Archibald Wheeler, who was a physicist and a cosmologist, he proposed this experiment. He says we've got Earth in space, and somewhere out in space there's a quasar. And a quasar is a very, very early object in the universe. So a quasar is going to be billions of light years away from Earth, and it's going to emit light. And if you can find a quasar where there's a star between the quasar and the Earth, the star is going to bend the light and have a lensing effect and bend some of those light rays around that star so they end up at Earth, coming from different directions. And this is John Wheeler, and a very smart man, wrote about black holes, quantum foam. And he actually did this experiment. And here's a photograph of a quasar being lensed by a star, and you can see the lensing effect in the rings that appear here. That's the outer edges of the lensing effect. And what you do with that is you have light detectors on Earth, and if light comes in from one direction, based on the lensing, and it hits the light detector set up to see it, then that proves that that's a particle. And if it comes in from the other direction, hits the light detector designed to capture that light ray, and it lights up, that proves it's a particle. Now that light left the quasar 3 billion years ago then as a particle, because when it gets here, it's a particle. When it hits the light detector, it's a particle. And it was a particle for the past 3 billion years. But if we take a semi-transparent mirror and put it where the two light beams cross, the light beams cancel each other out. And in order for them to do that, that proves that it's a wave. And that proves that when those two light beams left the quasar 3 billion years ago, they left as waves. But how did they know they had to leave as waves? How did they know I was going to put a semi-transparent mirror there in the way 3 billion years ago? if it's a simulation, and if there's a computer building that simulation, then the fact that I'm observing it means that the simulation has to account for the fact that I'm observing it. And there you go. Associate Professor Andrew Truscott from the ANU Research School of Physics and Engineering said, it proves that measurement is everything. At the quantum level, reality does not exist if you're not looking at it. The computer that's simulating reality then will only render what's observable to a player in the simulation, a simulated human. These simulations would not have to be perfect. They only have to be good enough to fool the inhabitants. Now, there's a computer game called No Man's Sky, where players, when they get into the game, they're allowed to go to any planet they want to go to. So they can pick a point in space and get in their spaceship and go to that point. And there are a possibility of 18 quintillion planets they could go to. Now, clearly, the game can't simulate 18 quintillion planets because, no laptop gaming computer is going to be able to do that. So what happens is the game doesn't simulate the planets until you, as a player, decide to go to the planet. So if you pick a point in space, you go to that planet in your spaceship, the computer says, okay, the guy's coming, let me build up the planet, what's the atmosphere like, what are the life forms like, what do the plants look like, and so on. So when you get there it is. And then when you leave, the computer stores that away in case you ever decide to come back, but it stops simulating it. So what about things that are very, very tiny and detailed, like you can use an electron microscope to look at a molecule. Well, what about that? You'd have to simulate all the molecules in the world in order to accommodate electron microscopes once they were invented. Yeah? Well, not really, because the simulator only has to have enough computing power to keep track of the fact that you're about to go look into a microscope and you're expecting to see molecules. So just before your eye hits the lens of the microscope, it simulates the molecules. And it simulates them in enough detail to fool you on an as-needed basis. If an error occurs, well, we can always edit the states of the brain that's being simulated to account for the anomaly and stop it from simulating the simulation, or stop it from spoiling the simulation. Or you could skip back a few seconds and rerun the simulation and avoid the problem. So you can even fix it. And that has interesting implications. That would explain how people have premonitions, right? Maybe you were in a simulation, you got on the airplane plane crashed and you died, but it turns out you were necessary for the simulation to reach the conclusion that the simulation is setting out to demonstrate. So we can't let you die. So we back up the simulation and then restart it and give you a premonition that says, don't get on that plane, and you don't. At the end of his life, Einstein concluded, space does not have an independent existence. He said, it is clear that the space of physics is not, in the last analysis, anything given in nature or independent of human thought. It is a function of our conceptual scheme. Space, then, is a function of mind. Eugene Wigner said, it will remain remarkable in whatever way our future concepts may develop that the very study of the external world led to the scientific conclusion that the content of the consciousness is the ultimate universal reality. Elon Musk says there's a 99.99% chance that the universe we inhabit is a simulation. And as proof, he serves up Pong. And I was a kid when Pong came out. You had a screen with two rectangles and a dot, and that was the state of the art in simulations. It was a simulation of ping pong. But now, 40 years later, we have photorealistic 3D simulations with millions of people playing simultaneously, and it's getting better every year. And if you assume any rate of improvement at all, then the games will eventually become indistinguishable from reality. And even if the rate of advancement drops by 1,000 from right now, 10,000 years from now, it's going to become indistinguishable from reality. And those games will be played on a computer that anybody could buy. And if you follow the dots, the base reality that the odds that we're in a base reality is 1 in billions. Neil deGrasse Tyson says that it's very likely we're in a simulation. He says, the day we learn it's true, I will be the only one in the room saying, I'm not surprised. Ray Kurzweil suggested that maybe our whole universe is a science experiment of some junior high school student in another universe. James Gates says, in my research, I found this very strange thing. And this is fascinating to me because as a computer scientist, I worked with error correcting codes. And what they are is it's a string of bits attached to everything in the computer's memory, so that if there's an error, you can look at that string of bits and calculate what went wrong and fix it on the fly. So if you got a memory where a bit is hit by an alpha particle coming from outer space and it flips from a 1 to a 0, the error correcting code will find that bit and fix it and flip it back. So he says, why were they in the equations, error correcting codes, that I was studying about quarks and electrons and supersymmetry? This brought me to the stark realization that I could no longer say people like Max Tegmark are crazy. And Max Tegmark is another believer in simulation theory. David Chalmers says what is happening today is support for the hypothesis that we are living in a computer simulation and that something has recently gone haywire with it. And he cites the election of Trump, the mix-up at the Oscars with La La Land and Moonlight, and the unbelievable comeback of the Patriots at the Super Bowl. I saw that game. Yep, definitely a computer simulation. Now, if Campbell turns out to be correct and we are in a computer simulation, then there is indeed an answer to Einstein's famous assertion, do you really believe the moon isn't there when you aren't looking? And the answer is, there is no moon. In 2019, Preston Green suggested it would be best not to test it, because if we find out it's a simulation, then that ruins the ability of the simulation to come to a reasonable conclusion. I mean, why is the simulation there? If it's there to prove a theory or to do a prediction of the future, if the inhabitants of the simulation know they're in a simulation, then the answer is not going to be right, and the simulation will be shut down. So maybe we shouldn't look too closely. And Max Tegmark says that we're in a simulation, we better all be very interesting people, because if we're not, the simulators might get bored and shut us down. Interesting thoughts. Seth Lloyd says the universe can be regarded as a giant quantum computer. And if one looks at the guts of the universe, the structure of matter is at its smallest scale, down at the Planck length, then those guts consist of nothing more than quantum bits undergoing local digital operations. The universe is a computer. And if reality is just information being processed by any kind of computer, then we're no more or less real if we're in a simulation or not. In either case, information is all we are. So questions we should be asking ourselves: is everyone a simulation, or is there a collection of players and players that aren't full simulations? They're just adequate. They're non-playing characters, right? Maybe that guy at that handed you your driver's license at Motor Vehicles isn't an actual person at all. He's just an NPC, and all he exists for is to hand out driver's licenses. That's it. Are you an NPC? Is the universe the computer, or is there a computer independent of the rest of the universe? So if the universe is the computer, then you can say, yeah, I'm real because I'm the result of the actual universe. Or is there a computer independent? So then, yeah, I'm a simulation. And is there a difference? Is our collective consciousness the computer? A lot of people are starting to think that these days. Or is there even something else? Is there a base reality somewhere? Or is every simulation just built on another simulation? It's a big loop. Where in the simulation hierarchy are we? Are we at the base level? Are we at the second level? Are we at the third level? What happens if we're at the fourth level and some computer at the second level breaks down? What are the implications with regard to morality and ethics? If you're a simulation, are you responsible for your own actions? Is this a model of a decision point? If it is, what is the decision that's going to occur? And when is it going to occur? Because when it happens, right, and you get the proof you were looking for, does the whole simulation shut down? Does it start over again? Are variables tweaked and it's rerun? And if so, are we going to be in it? And should this change the way we behave, or should we just go on as we are? And those are my thoughts on the simulation hypothesis. And now we're back. I can't hear you. There we go. I just turned my camera back on. And your camera is off. And I don't know if you can hear me. I can't hear you. I can't hear you. I'm going to leave and come back.